Welcome to our next Real Virtual tutorial. This time I'm going to show you how to grip parts, for example for pick and place operations by robots, and how to define simple logics and process steps based on LogicSteps. So let's start. What I prepared for today is based on our last tutorial. I inserted a robot model into the scene, and the robot model I downloaded it again from 3D Find It, this Epson robot here. I included the robot into the scene as learned before, and what I did, I assigned the robot to a kinematic group and integrated the kinematic group down here below the y-axis, so that when starting our drives, I would need to set that to always active, the position again, that's what I turned off. So when I start my simulation, the attached robot is moving with our gantry. For the moment we don't care about the robot kinematic, so it doesn't matter at the end what you place here. You could use anything else, even just a simple box. This robot kinematic itself, we are going to take care about it in one of the later tutorials. For the moment we just use it as a basis for gripping things, and we won't move the robot itself. First of all, I'm going to show you how to define simple logics without the need of programming real PLC code on the PLC itself, or without the need of really writing C# .NET code within Unity. The simple logics, we have implemented them as so-called logic steps. Do not replace real programming, but for simple things, it's a fast and easy way for developing your own functions. I would like to use this simple logic steps for first moving our gantry, including the robot, to a position where we could later on grip this part here. So I'm creating an empty game object, call it logic, and for the robot drives I've got still, for the gantry drives I've got still this test script on it for moving them to a random position. I'm removing these components because I would like now to control the positions by my logic. There are several logic steps included in Real Virtual, and you can add several logic steps to one game object in here. And first of all, we would like to drive the robot to a certain position. So we've got the logic step start drive to, and this will start one drive to move for a certain position. It won't block, so this step will take 0 time and will directly start the next step. So first of all, we are starting our z-axis to a position, and I already know, because I tried it before by manually moving, that the position should be 1686, I think, millimeters. And I'm adding another step drive 2. That's a blocking logic step, so he will stay in this step until the drive reached its position. And I would like to move this axis to my position of 4.5 it might be. And I'm adding another step. For the moment, wait for a signal. Wait for signal bool. I'm creating another component in here. I'm creating an empty game object signals, and I'm creating a PLC output bool. Restart. It's set to false, and in my logic I'm waiting for the signal to be true. I'm just doing that for the logic step to wait here until for the moment until forever, because otherwise the logic step will, this chain of steps will restart automatically. That's the standard behavior. So the code or the simulation will finish it here and restart with the first step again. So let's see if this is working right now. I'm starting the simulation. Okay, it's very slow, so I should speed it up by setting a different speed to it. Here it is. So for the speeds, it has been 100 millimeters, so let's make it to maybe 800 millimeters per second. So once again, it's okay. We are colliding with the components, so we could later on pick them up here. And what I'm going to do here, just for testing purposes, manually, this sensor here, I'm moving it to a position where I need it somehow. It might be somewhere here. And for copying this position to the scene, because I'm still in play mode, I could copy here the position, and now on the sensor I just paste the position. What I did is changing Y and Z axis here, so that my longer moving axis here is the drive 2, and then we are here waiting for the restart signal. I'm now going to do another logic step, and so let's call that logic for the handling, and I'm creating a new empty game object for the logics of our conveyor. Logic conveyor, just for stopping as soon as our goods reached the picking position. I'm going to add a new signal, PLC input bool, which will be sensor occupied, and I'll select the signal here in my sensor, and on the logic I'm adding my logic step, wait for signal bool, it should be true, the sensor occupied, and now I'm setting the drive speed of my conveyor. Just checking, where's my conveyor? Here's my conveyor drive. So I'm on my logic for the conveyor. I'm setting the speed to 0. So let's see. Sorry here for the conveyor. I don't need to set it. I need to wait for it. Logic step, wait for signal bool. Put it on the as a first step. This signal, and I'm waiting for true. Okay, so my goods are stopped, and now I can take care about the picking of the goods. But before doing this, you see that always this logic is on, and that's because it's now iterating very fast between all these steps. So and that's why we should wait here for the signal to get false again. So sensor occupied false. I know, again, I need to wait for it. Logic step, wait for signal bool, and this one. And I'm waiting not for true, I'm waiting for false. So now you should see that he's standing in the last step. And now we are in the last step. And for being able to start it again, we need another logic step that we are starting the drive. Logic step again, the same drive. And with a speed of, let's put it to 200, spin 200. Let's check here. Our speed of the drive is 300. So in our logic for the conveyor, let's put in here 300. And as soon as the true is back again, it will start. Now he's waiting in here. I can pick the component, moving it away. It will start and stop again. So my logic for the conveyor is finished. Now let's start with the gripping of the part. For gripping, we can put on our robot here on the top a grip script. It's also available here in the overlay. And for defining the part which we would like to pick, we also need a sensor here. And we are going to use it as a raycast sensor. Okay. So the 0 point is not as I would like to have it. So I'm putting here a new empty game object. Let's put in here the sensor. And I'm moving the sensor down to this component. And now I'm able to move my sensor to the position here. in front of my robot, and 200 millimeters is enough. So this raycast here, this sensor, will detect the components we would like to pick, and in our grip script we need to assign the sensor and exactly the sensor which is detecting the part which we would like to pick. I'm adding a new signal here for picking. Let's call it pick. And in our grip script, we are having two signals, pick and place. So we need another signal which is called place. And both booleans, when they are going high, they are going to pick or place our components. So I'm here pick and place. On the sensor, we need to take care that the sensor is raycasting on the layer where we wanted to raycast, but it's raycasting on layer MU and sensor MU, so that's totally fine. We'll be able to detect the part. And so let's check if our sensor is detecting the parts. No, not this sensor on our robot. And I would need to select it here. So it's here, and you can see in the status of our sensor that it's triggered by the part. And yeah, it's getting red, but we don't see it because it's hidden by the part. So we detected now our component, and basically by putting the pick too high, we would be able to grip the part. And for doing this, I'm going to extend our logic steps. So on the logic for the handling, for the conveyor, we are going to wait for the same sensor. So logic step wait for sensor, for example. We can select the sensor on the grouper which detected the part. We are waiting for occupied. No, we are not going to wait for this sensor. Sorry, because he will directly pick it on the tip. I'm preferring to wait for this sensor on the conveyor. So it would be better sensor gripping to rename it. Gripping and the sensor on our sensor conveyor. So here on my handling logic, I'm going to wait for the it was on the wrong position. So for the logic handling, I'm going to wait for my sensor on the conveyor so that the part arrived here and I can pick it. I'm now adding the signal for gripping it, for picking it. I'm setting it to true. And for testing, I'm driving my drive upwards to the destination of 0 again. What I need to do now is my restart signal for the whole logic. When it's finished, I'm going to put that to the end. Sometimes it's hard to move, so now my restart signal is at the end. Now let's see if everything is working as expected. No, it's going directly up, and okay, that's because we are not waiting here for occupied on the conveyor. So I'm changing this and testing it again. He's moving through the position, he's waiting, and he's moving up. And we fixed and gripped the part, and by selecting here, by forcing the place. So first we need to turn the pick off to true, it will fall down. That's our first picking operation by using this grip script. It has a lot of additional options, for example, for aligning things while picking it. But easiest way is just to assign a sensor. And this sensor here on the tip is needed for detecting the parts to a grip. And with two signals, we can pick and place it, and the gripper will always pick it when the signal is changing from false to true, or from for picking, or from false to true for placing. So it's only reacting on the change between false and true. For finishing our operation on the handling side, I would also like to drive to the side. So we add a new logic step, drive to the z-axis. Before we drove to, okay, let's drive to maybe 3000. And we are going to release our goods. We are setting the signal pick to false, and we are setting the signal place to true. And this restart signal, we don't need it anymore. So after he's placing it, we can restart the logic. So I'm going to remove this restart. And what I wanted to achieve, that we are continuously gripping or picking and placing the components. Okay, we missed something. So on the handling side, we are placing, setting it to true, but we also need to reset it. So LogicSteps, set signal true, place, our place signal, we will set it to false, maybe on the beginning of our full chain. anywhere here. So once again, so something is wrong. Set it to false. I need to check. Doesn't seem to, okay, it's setting place to true, but directly he's jumping into the first step, start drive 2, which is not waiting. So it will directly set it in one physics step again back to false. That's why it's not working. So we need to move it after this drive 2, which will take some time. So once again, we're waiting for the sensor. We're moving here. And our simple model is running in a loop. Still, the robot isn't, like the real robot, moving with a kinematic and inverse kinematic and so on. We'll do that in one of the later tutorials, but that has been the first tutorial for showing you how to pick and place parts with the grip script. There are additional ways for gripping, like for example using the fixer, and I'll explain you the fixer in one of the next tutorials. Thanks a lot for this tutorial, for watching it. Please subscribe to our YouTube channel, and I wish you much fun with revirtual.io. Thanks a lot. Bye bye.